The next feature that I want you to be able to identify or discuss would be a caldera, and we have one of the best calderas in the world, Crater Lake. So a caldera is a remnant of a former stratovolcano. I don't know if this should be, I have to Google this and see if that should be one word. Okay, so they're a former stratovolcano. So what you know about that is that these are very explosive landforms. And basically, the caldera is the remnant. So when a stratovolcano has a catastrophic eruption, what will happen is that all of the material under the volcano will be evacuated. So for instance, if this volcano were connected to the magma chamber down below, and for some reason this decided to have a super explosion, all of the support under here could be evacuated out the crater in the form of ash and lava and pyroclastic bombs, leaving nothing left for the sides of this volcano to be supported with, and so it will collapse in on itself. And that's what happens with a caldera. So Crater Lake, you can see kind of the edges of this and imagine a really huge stratovolcano sitting on top of this that erupted, removed all of the sediment and support underneath the volcano, and the walls just collapsed in on itself. So at some point in time, about 7, almost 8,000 years before present, Mount Mazama was in this location at 12,000 feet of elevation. It was a very high volcanic strata mountain, and when it erupted, it left a crater 5 miles wide, and it's one of the deepest lakes, or it is the deepest lake in the U.S., 2,000 feet deep. The ash went into the upper atmosphere. There is ash from Mount Mazama in Greenland. When they find stratigraphic layers in the ice in Greenland, they find Mazama ash from that. Just a huge, huge explosion. This also in California, there's a caldera called the Long Valley Caldera. And this area also historically had a huge volcanic eruption. Let's take a look at this. And this is somewhat still active. There is a resurgent dome, so it's building again. But they have volcanic material out on the edges from before the caldera was created, and this is, what is the scale is 2 miles here, so it's a very large basin in the Long Valley area. And so this is kind of this old caldera. They have rebuilding here, and so it didn't fill with a lake like Crater Lake did, but it was huge, and they think the ash from that went around the world. Sometimes through the process of erosion, hardened internal structure of volcanoes can be exposed. So that can be lava in the vent, or lava in the connecting ports. And so one of the classic features in the U.S. West is shiprock. And so this is a volcanic throat. These are volcanic pipes, so lava that hardened, and the landscape around it or over it has been eroded or removed, leaving just this the bones of this volcano. Here's the Devil's Post Pile, which is another volcanic throat that hardened and was more resistant than the material around it, and so that's all that's left on the landscape. In Washington and Oregon, there is a landform called Plateau basalts, or the Columbia Plateau, and this is a result of eons of very thin basalt lava, effusive lava, that flowed out through cracks along the Snake River Plain. Some of this lava flowed from the Snake River all the way to the Pacific Ocean and created these very deep landscapes, so very low viscosity, and it covered about 200,000 square miles in the Columbia Plateau up to the coast. So these things were just ancient landforms that created Multnomah Falls and some of these great hiking and tourist landscapes in the area. Sometimes a stratovolcano will have a superheated event where the snow water on the mountain will flash melt and then get mixed with the mud, and these create hot mud flows that move at just amazing speeds down the mountain, and it's called a Lahar. In 1985, in Nevado de Ruiz, more than 23,000 people were killed from this volcanic event, and many of them were killed in these mud flows. And there's no time, especially back in 85 when we didn't have great warning. And in some of these rural areas in the world, there isn't warning systems. So you get just this great volume of mud and rock and ash that's superheated, moving down the mountainside. Pyroclastics can be what people think of as pumice. So pumice is often pyroclastic ash that's blown up into the air, and it can fall back down and create these very deep landscapes. It can be those fine pumice bombs, or it can be heavy rock that gets blown into the landscape, and you can see that these are ash layers that have just built up. Can you imagine how much ash had to come out of a volcano to create this deposit that's taller than this person? And it's huge. If I had backed up the camera, but then within those ash falls, you get a mix of large pellets of ash, small pieces of ash, huge rock fall. So these are very dramatic flows. In addition to the Lahar, the hot mud flow, often a volcano can have a what's called a superheated ash flow, or a nuee ardente, and this is what killed the people, the event that killed people in Pompeii. So it's superheated ash that is in almost a molten form, but it's not flowing on the ground. It's coming down in a wave of a wall of ash that just covered people where they were, and that's one of the things that killed people in the Mount St. Helens flow. There was some ash flow and bombs. So it's so the Mount Pelée was the one where we had the ash flow. And it's interesting to look at the deaths, primarily historic, as a result of many of these large events. 25,000 people in Colombia from the mud flow, 29,000 in Mount Pelée from the ash flow, 36,000 in Indonesia from a tsunami in 1800s, 92,000 in Tambora, Indonesia. This was from starvation. And so when you look at these volcanic landscapes, here's one in St. Pierre on Martinique Island in 1902. The eruption killed 25,000 people. But one of the benefits of volcanic landscapes is that the ash is very fertile. When just think about trying to create fertile soil, you need rock to be broken down into its elements, and that can take a lot of time. But when you have a volcanic eruption and ash is spewed on the landscape, that ash can be very fertile. So these are good places for people to live in terms of good soil to make a living, but they're also very dangerous places for people to live. And you can't, so I'm looking at the Tambora event where 92,000 people died of starvation. So if you're in an isolated area and you have an ash flow that covers your island, yes, that's very fertile. But if the whole island is covered, it will be a while before you can actually grow food on that landscape. So these are places where people historically have lived because the soils are good, and yet you're at risk when you're living on the Ring of Fire or in other areas with active volcanoes.